When you think of a black hole, what's the first image that comes to mind? For many, it's a dark matte hole resembling a rabbit hole that sucks anything that gets too close inside with an unknown fate. We generally understand black holes as an immense cosmic phenomenon where the pull of gravity is so strong that nothing, not even light, can escape. But what happens when two black holes collide? Will they combine to create a larger black hole, or will they explode? Is it possible for us to observe the merging of two black holes in our lifetime? Curious? Then sit back and relax because we're going to explore the possibility of witnessing the fusion or destruction of two black holes. And if you enjoyed this video, please give it a thumbs up so we can continue to make more videos and uncover more scientific facts and mysteries from around the globe. Black holes have been a part of our universe for a very long time, and their origins remain largely unknown. The discovery of black holes is attributed to John Michell, an artist who was an also brilliant and innovative scientist. Michell was the first to apply mathematical statistics to astronomy, which allowed him to study the distribution of stars in the sky. Through his observations, he discovered pairs and groups of stars that could not be accounted for by random alignments. However, his most remarkable idea was the concept of black holes, which he developed in 1783 while considering a hypothetical method to determine the mass of a star. Seriously, these scientists are amazing just imagining the existence of a black hole acting like a vacuum in the sky. Sadly, like most early scientists, Michell's concept was not well understood by his fellow scientists, and the idea was hidden for centuries until it was rediscovered in the 20th century. Even though black holes have a significant impact on the space surrounding them, the belief that they behave like cosmic vacuum cleaners and devour everything in their vicinity is a popular misconception. If the sun were to collapse and become a black hole, the planet's orbits would remain unaffected because the central mass would remain the same, and the planets would feel the same gravitational pull as before. What sets a stellar black hole apart is its small size and high density, allowing other objects to come very close to its center of mass, where the gravitational force is incredibly intense. Nevertheless, this does not increase the gravitational pull far away from the black hole, and we thought it can eat our world up. Due to its incredibly strong gravitational pull, a black hole appears as a completely dark, lightless entity that can only be detected by specialized tools. Astrophysicists can observe the movement, size, and mass of stars in the universe to identify black holes. Astrophysical theory suggests that black holes can vary in size, with the size being proportional to their mass. For example, a black hole with the mass of the Earth would be roughly 1 inch in width, while one with the mass of the Sun would be a few miles in diameter. A black hole with the total mass of the Milky Way galaxy would be around a light year across. The larger the black hole, the lower its average density. And it has been theorized that our entire observable universe is a supermassive black hole located within a larger universe. If two black holes collide, what do you think will happen? Well, a recent study using NASA's Chandra X-ray Observatory, located in Chandra, Massachusetts, has identified two pairs of supermassive black holes in two different dwarf galaxies that are on a collision course. Apparently, these two galaxies are carrying supermassive black holes alongside them and is in the process of colliding with each other, which also resulted in the collision of these two supermassive black holes. This event could provide scientists with important information about the growth of black holes in the early universe, which is pretty darn amazing. The Chandra telescope was useful in the study because materials surrounding black holes can be heated up to millions of degrees, producing large amounts of X-rays. Black hole number 1 is located in the galaxy cluster Abell 133, 760 million light-years from Earth, while the other was found in Abell 1758s, a galaxy cluster about 3.2 billion light-years away. Scientists believe that these two pairs are in the early stages of a merger, causing a bridge of stars and gas to connect two colliding galaxies due to their gravitational interaction. Talk about force of attraction, these two are on it. The team looked for pairs of bright ray X-ray sources in colliding dwarf galaxies as evidence of two black holes and found these two examples. What's more, the collision between these two galaxies caused a triangular-shaped star birthing event in NGC 2445, and it can be seen from the NASA's Hubble Space Telescope. It is believed that the galaxies that are passing through each other is creating a unique star formation event where thousands of stars are being born and worn out. Since NGC 2445 is rich in gas, this event is made possible with the rich fuel to make these stars. According to Julian Dalkinton, Flatiron's Institute Center for Computational Astrophysics astronomer, simulations show that head-on collisions between two galaxies is one way of making rings of new stars. Therefore, rings of star formations are not uncommon. What's weird about this system is that it's a triangle of star formation. Part of the reason for that shape is that these galaxies are still close to each other and NGC 2444 is still holding onto the other galaxy gravitationally. NGC 2444 may also have an invisible hot halo of gas that could help to pull NGC 2445's gas away from its nucleus. So they're not completely free of each other yet, and their unusual interaction is distorting the ring into this triangle. The intricate dance between the two black holes and their accretion disks creates a mesmerizing display of light and gravity. As the black holes orbit each other, their respective accretion disks become more distorted and take on a characteristic warped appearance. When one black hole passes in front of the other, its gravity bends and magnifies the light from its partner's accretion disk, creating a sequence of rapidly changing arcs. This effect is known as gravitational lensing and is a consequence of Einstein's theory of general relativity. The different colors of the accretion disks, red and blue, help to distinguish the light sources, but in reality, both disks would emit most of their light in the ultraviolet range, with the blue disk being slightly hotter. The visualizations of these phenomena provide astronomers with valuable insights into the behavior of black holes and the dynamics of their surroundings. Relativistic aberration is a phenomenon in which an object appears to change in size or shape when viewed from different angles and at different speeds due to the effects of relativity. This effect occurs because light emitted from different parts of the object reaches the observer at different times, depending on the observer's position and motion. In the case of visualization of the orbiting black holes, this effect causes the black holes to appear smaller when viewed from the direction of their motion and larger when viewed from the opposite direction. The study of these merging black holes and dwarf galaxies can offer valuable information about the history of our own galaxy, the Milky Way. Many still think that the two merging black holes will explode, while some too, it may just to cause a strong ray of light to pass through our galaxies. I think it might cause a massive shockwave and bring destruction to nearby galaxies around them. What are your thoughts? Let me know in the comments below, and if you enjoyed this video, please hit the thumbs up button to encourage us to make more videos in discovering additional scientific facts and mysteries from around the globe.